Hey everyone, in this video, let's take a look at question 226, invert binary tree on Leetcode. This is part of our blind 75 list of questions, so let's begin. In this question, we're given the root of a binary tree, and you want to invert the tree and then return the root in the very end. What does this kind of look like? Well, if you take a look at the root doesn't change, but the children do change, right? So this entire subtree, and actually maybe it looks better if I do it on paint here. So this entire subtree here, first of all, it goes to the right hand side. So initially it was on the left hand side, and then it goes on the right hand side. Not only that, but the 1 and 3, the children of the 2, also get inverted. So they become the 3 and 1. Similarly over here, the 7, which was initially part of the right hand side, now goes to the left hand side. And not only that, the 6 and 9, which were the children of 7, now become 9 and 6. And you can actually think of this in terms of like a simple scenario here. If we had something like this, 2 and then left is 1 and then right is 3, then the 2 remains the same. The root always remains the same, but the children get swapped. It becomes 3 and then it becomes 1. So how might we go about doing this, right? Like, what is something that we might want to do? Well, with any type of like tree problems, we like to handle them in a recursive case, right? Because recursion is often the most simplest, the most intuitive case. So maybe we can just start off with that. And one thing I think I know right off the bat is tree can be like none, right? So if tree is none, then we can just return none. So maybe let me just handle that case right away. If tree is none, then I would just return none. Otherwise, I like to have my helper function, and here it looks like we just need to pass in the root. We don't really need anything else. So we pass in the root, and now again we can handle our case where if a root is empty, then we can just return empty, right? We don't need to process it. But now what? Well, in these types of recursive problems, right? The thing we want to do is we want to take a leap of faith. So there's often a kind of a structure to these binary tree problems. We want to go ahead and recurse on the left hand side, the left child, and you want to recurse on the right child. Right? We want to do this. Now, we want to take a leap of faith. What does that mean? Well, we want to assume that recursing on the left hand child, let me go ahead and do this. Recursing on the left hand child will give me something like this. It'll give me the left-hand child where the children are all inverted. Similarly, recursing on the right-hand side will give me something where the children are inverted. You can see here the 6, 9 becomes a 9 and 6. The 1 and 3 here becomes a 3 and 1. We want to kind of take this leap of faith. That's how you kind of approach these recursive type problems. You recurse and then you assume you already have the answer. So we assume that from a recursion, we already have this and we already have this. The only problem is that we have them in the wrong location, right? Because when the recursion returns, this thing here will actually be right over here, right? And then this will be right over here. It's the correct answer downstream, but upstream it is not. So what we need to do is we actually need to swap them. So what we can do is I can do root.left is equal to right, and then root.right is equal to left. And now what do I need to do? Well, now I basically need to return my root, right? Because let's say I'm at the 7, then I need to be called by the 4, right? So I'm going to return 7, which is the root, back to the 4. Now, let's go ahead and run this code to see if it works. And we can go ahead and submit it. And we arrive at the answer. So perfect, that's how you do this question. It is O of n time because we are basically just going through all of that once. And then really space is constant, but you have recursive space, so you can maybe take that as you will. Okay, thanks for watching.